everyone, my name is Diva Banzara and today I'm here with my team member
Maya
and Zachary.
And our mentor is Bruce Benjamin. So we're the members of Robotics project, you already know that. So some of you guys already know what our project is, but I'm gonna explain it again for the new members and the members who want to join our project in future. So this project provides the platform for students to flourish their skills like programming, 3D designing, and assembling of the robot. And
There are three objectives regarding our project that we intend to complete. These are building a robot that satisfies the regulations for the VEX Turning Point competition, understanding how certain systems and mechanisms work and how to utilize them, and honing our skills with using tools, programming in Robot C, our robot's coding language, and 3D modeling and printing. So if you weren't here last semester, this is the Turning Point competition setup. So you've essentially the red and blue sides of the board, gold platforms, discs that need to be toggled and or stacked, and flags that need to be toggled.
during summer one, we built different prototypes with different mechanisms. So one of the prototypes we built during summer one is this. I use catapult mechanism for the ball launcher, which will help us to launch a ball at a certain angle and with a certain speed.
The extending claw itself is more or less complete. Future modifications may be necessary. A rack and pinion extends the arm. Rack and pinion extends and retracts the arm, while the motor in the wrist, if you wish, allows it to rotate. This will enable the robot to flip over and mount the discs, toggle the alarm mode's flags, and load the catapult mechanism. Now wasn't really finished yet, sorry. Now, we're currently working on a way to raise and lower the arm, as well as mount it onto a turntable. Now, due to the claw's weight and overall configuration, we may need to use a hydraulic cylinder to achieve the former task. The competition's rules do permit the use of hydraulics, but doing so reduces the amount of motors we're allowed to use. The turntable will enable the arm to swivel, but the arm may need to be mounted on the side of the robot on account of the catapult. The robot should be able to rotate to help counteract the reduced workspace. Right. Next slide.
Okay, one of the objectives of the game is to park in the central park for extra bonus points of 12, which could be crucial in winning the game. This is for one color robot to park here and for the other platform. However, when time is up, if you secure the central parking, then it's a bonus of 12 points. So we aim to build a prototype that will help us secure the central parking. And here are some of the attempt designs that we made out of cardboard and tape. Just to demonstrate first to see if it was working. And it was suggested by one of the STEM members, Tyler. He was in many competitions for battle robots. And the idea is to have a sliding shield where when the other robots attempt to knock us over, it will be trapped. And we will create a gap in mass and its weight, lifting the first wheels up and knocking it back over. And oh, there's... So when we tested that design, we noticed that because the two sides are exposed, our main objective is speed, which is crucial to winning the entire game. So we don't want to add more parts. The other challenge is we're limiting to use of motors. So the main idea remains to create the curve, and we found that the best curve is hyperbolic curve. To not use motors, we thought about the Asian fan, the way it unlocks and locks. So we would just have to press a button and it will open a shield, open up the shield. And we were also inspired by mimicking a bird's wing. So our conclusion is, for summer one, we worked on prototype of different mechanisms for our robots. For summer two, we are going to work on installing those mechanisms to our robot. And to reach us.